After RADARSAT, I came back to Ontario and with Sora and a few other people. I had the privilege of working on one of the other Canadian icons, which is the Canadarm2 space station remote manipulator system that was deployed to the space station in April of 2001. So my job was in EVA, extravehicular activity preparations, basically writing procedures for, or helping to write procedures for the astronauts for the various tasks that they have to do. It was really, what was really interesting, well, there were a lot of interesting things, but just as an inside thing, I was fascinated by the level of detail of these procedures and how, in a way, we kind of treat these people that have multiple degrees and are like orders of magnitude smarter than I'll ever do. We kind of treat them almost like children. So it's literally like step 47, loosen bolt, set torque tool to counterclockwise, and then like literally it's step by step by step. And it seems silly at first until you realize how valuable crew time is up there, how expensive it is to get up there, and literally every minute counts. I was rewatching an episode of From the Earth to the Moon, and I thought there was some kind of figure that each minute of an astronaut's time on the moon was the equivalent of like $1 million or something like that. So it seems a little pedantic, but these careful little things that are done, it turned out actually made a lot of sense. A couple of years later, because of Marc Garneau, who was at the president of the Canadian Space Agency at the time, he had a real vision and a real push that Canada ought to be involved in Mars exploration in a really big way. And while unfortunately, again, a lot of that didn't come to fruition, there were plans that Canada would actually have its own Mars mission out there. That never happened, but a bunch of other really important things did. One of which was that Canada would provide a meteorological station for the Phoenix Mars lander, which touched down in the summer of 2008. So this was a pressure and temperature sensor and a meteorological LiDAR that could take returns and sample the lower boundary layer up to about 5 kilometers, suspended particulates, and so forth, and getting that profile for the first time. So here, this is an animation, but that's one of my favorite pictures over there, is the thermal cover of the LiDAR transmitter and receiver, the thermal blanket, actually had the Canadian flag and the Canada word mark on it. So there is a Canadian flag on Mars as we speak. And I remember being at Caltech. I had the privilege of being at Caltech at the moment of the landing, and it really was an unforgettable moment. It was an unforgettable moment, not, well, of course, yeah, the technical achievement, of course, but the best part of all of this, and the best part of everything that that we ever do, the best part of what I experienced is that bottom right picture there. It's the really cool and incredible and talented and dedicated people that I've been able to, that I've had the privilege to work with in industry and in academia, in different space agencies around the world. That's really been the best part of this job. You don't need to motivate people to work on this stuff, and it's just such a special group of people that seems to be attracted to space and space science and astronomy. So that's it about me. I don't want to talk about me anymore. I would much rather talk about ComDev. And I suppose the thing about ComDev is I have to confess myself that I didn't really know very much about the company before I started back in September. And in a way, it seems almost stereotypically Canadian that, here's a company that's maybe not so large in the grand scheme of things. I mean, about 1,200 employees worldwide. That's certainly not to the level of a Boeing or a Lockheed Martin or whatever, but sort of medium-sized company, but really doing some pretty cool things in space as part of the Canadian space program and the international space efforts. So ComDev has been in business for over 35 years now. We've got about 1,100, 1,200 employees in 4 sites. So The headquarters is not too far from here, of course, in Cambridge. We also have a facility in Ottawa, which is where our space science and electro-optics group is based. We have a facility in Britain, in the United Kingdom, near the London area, and that's our beachhead into the European Space Agency, European space market. And one of the more recent developments in the last couple of years is we've established in the United States as well. So there's ComDev USA in the El Segundo area of Los Angeles near the airport. And that facility is dedicated to American work, particularly work of a defense and security nature that Canadian companies would normally not be able to participate or bid in. So it's kind of firewalled from the rest of the company in the sense that it's only Americans and American citizens and green card holders that are allowed to work there for really messy reasons that I probably won't talk about. Customers, being around for almost 35 years, as a Canadian company, we've worked with just about everybody in the business in terms of not just the big commercial primes, the Boeings and the EADSs and the Lockheed Martins and General Dynamics of the world, but also space agencies. Of course, our own space agency is a big customer. There's actually one logo that's not on this slide is DND, Department of National Defense. We do a lot of work with DRDC and DND, European Space Agency, and most recently some work with the Chinese and Israel, the Indian Space Research Organization. And we have a really good relationship with Israel in terms of procuring rides into space, and I'll talk a little bit about that. This was a pretty cool fact that I didn't know. Again, one of these things that was new to me when I joined the company was that, in fact, we have about an 80% market share in the things we do for commercial satellites. So just to back up a little bit, the bread and butter for the company for most of its existence, for most of its 35+ year existence, is in components and subsystems for commercial and military communication satellites. So filters, muxes, switches, waveguides, and that sort of thing. And in fact, our equipment has flown on over 700 satellites to date without a single on-orbit failure. There was a failure of a Japanese probe to Mars called Nozomi that had one of our instruments on it, the thermal plasma analyzer, but that was a failure of the spacecraft, and unfortunately our instrument never got a chance to show its stuff in Mars orbit. This ugly slide is really just describing some of the highlights of the missions and payloads we've been involved in. We built the diplexer for the Cassini mission to Saturn. Nozomi I talked about. There's a few others here. RADARSAT and the follow-on RADARSAT Constellation mission, which is the 3 small satellites are supposed to be the follow-on to RADARSAT-2. And really the crown jewel of our efforts right now, sort of one of our flagship programs, is the JWST, the James Webb Space Telescope. So this was the pretty splash slide that you saw at the beginning. JWST is the follow-on to the Hubble Space Telescope, and Canada has a major role in that. Some of our capabilities, as I